All right, let's try this again. See how it goes. It looks like I have an excellent connection. Just checking for at least some video to pop up and then double check the audio. Then we'll get into the course tour for our winter session of computational mechanics. So it looks like we've got video to pop up, double check audio. We got audio, we got video, we are ready to rock. Okay, here we go. Welcome to our winter session of ME3255, Computational Mechanics. This is a very quick course, so over the next 3 weeks, really it's like 13 days because we have New Year's Eve, New Year's Day coming up. So we've got two weeks of 5 business days and 1 week with only 3 business days, depending on what your travel plans are or kind of party plans. So we're gonna move quick, and that's okay. We'll do it, we'll get through it. So if we look at due dates for the class, which I swear I made the due dates. Let's see, homework 1, due 1/2/26. That one's right. Reading coach, due 12/30. So it should be in the calendar. Here it is. So coming up, here's like on the 30th, so the second day of class, turn in a reading coach, and I'll go through kind of what these assignments look like. Take 2 days off for New Year's Eve, New Year's Day, and then homework 1. And then coming into January, we have our 2 full weeks where we're gonna one day after another, project 1, reading coach, homework 2, project 2, reading coach, homework 3, project 3, reading coach, homework 4, project 4, and then homework 5 and project 5. If you are doing really well with this material and you want to try something new, the module 5 is a great way of connecting a lot of the concepts and skills that we're working on into some new applications. Or you can always go back and revise previous work that we've done, because as we go from module 1 through module 4, the things that we tried in module 1 are going to feel a lot easier because we've been like working on so many different skills as we go through and like learning as we go. So anyway, that's a quick tour of like the timeline of what we're doing. This course tour is right here in this button there. This course, I've been teaching it for a while now, and I maintain kind of different, so each semester I record videos live, and then in previous, let's see, should be another winter. Here's like summer sessions, and coming down here, winter sessions. So in summer and winter are usually more focused videos on things where I see there could be improvements made to homeworks and projects that we were working on. Meanwhile, the fall and spring videos, those are usually more interactive troubleshooting. So sometimes there's longer, because these are an hour, and some of these summer ones are, well, some of them are an hour, but sometimes they're only like 30 minutes or 20 minutes. But anyway, there's lots of, so if you're interested, you can always go there and kind of take a look at previous work that previous suggestions and work that we've done. Course syllabus, I keep this one updated on this website. So now we're here in the winter 26. All of this course material is hosted on GitHub. So you can, here, if we go to this is called the GitHub repository. It's where all of the assignments and all the readings, they're all contained inside this website, inside this repository of of stuff. So you can always, you could star it. You can click on my logged in fork. You can click on this fork and it says make a fork a copy. So you would have to log in, create a GitHub account, and then you would have your own computational mechanics that is the same, like it'll keep track of the same changes that I've made, and you can always look for changes that I make later. So this is our syllabus, and again, we're going through 4 modules, plus there's a bonus module if you have time and you're interested. And it's a great combination of a lot of the concepts that we're building towards in modules 3 and 4, and even some of this like analyzing data, or this one really in 3 and 4 we're doing like predictive models of like we know what forces or kind of the physics behind something, so integrate that or solve an equation to get to somewhere, and that's what the boundary value problems are doing here. We're using Python in this course, so it's a hands-on like Python work. I don't expect you to have like object-oriented programming down pat. We're really not getting into the concepts of like object-oriented programming. We're just using Python because Python is cool and it's fun. So some expectations is that it's okay to copy and paste like from a textbook, or nowadays ChatGPT or Copilot, and we'll take a look at the Reading Coach, which is an AI generated or an AI bot that's meant to help with the course. That's totally fine, but when you are copying and pasting code, this is something that you should be able to read through, understand, and for the most part, there should be some kind of editing. Like you should be changing it, whether it's documentation for it, the way the variables are named, something, and definitely post and share examples or error messages, help other students with this. But the one thing that I ask that you don't do is just grab work, either somebody else's work or AI generated work, and just paste it in. It works, and then just claim that it's yours. Because if you didn't do anything to understand it, then you can't really claim credit for it. And prompt engineering is not like academic, it's not intellectual work. I know you do have to like type and kind of interact with something, but it's not actually counted as something where you're generating, like you yourself are generating intellectual property. And this is something that's come up for like American copyright laws. Like you can't copyright an AI generated work, and ideally you should be able to copyright your own schoolwork. So that's where we're at. So coming back to like posting discussions and things, what I'm trying this winter is a little bit of an experiment. I should have opened that in a new tab. Let's do that. A little bit of an experiment of trying out Microsoft Teams for our discussion platform. It's not my favorite like discussion forum, but we all have default Microsoft accounts, so we can everybody can join here. We can introduce ourselves. So that'll be the first thing that we do. Is just post about like who we are, what, and how we're connected. This is the main, and again, it's an experiment, but this should be the main interaction in the course. Like post your questions in our computational mechanics general, and if we need more channels, we can add channels. But this is where we can talk about like due dates or problems with the class or how to solve things, what errors come up. It should all be here. Individual emails, just they don't work. You can't troubleshoot code through email. I've tried, it just doesn't work. Like screenshots of things that make no sense. So we'll try that. We'll give the Teams discussions a shot. And you should be able to click on this link and join right up, but let me know what happens. So running Python, if you want to run Jupyter on your own computer, you're welcome to download. Again, you can download this whole thing. You could download a zip file, or you could clone this to your computer. But the code is all there, so you don't have to use this software that I'm offering. But I partnered with Purdue University and created this nanohub.org computational mechanics open educational resource. It takes the entire website and turns it into Jupyter notebooks that we can actually interact with. And we need NanoHub. This is kind of an aside, but if you don't have a password manager, try one out. Go find a password manager. I like Pass, P-A-S-S, because it's great. You need all sorts of accounts these days. You need something to keep track of them, and you need them to be safe, something to generate some passwords for you. So now we're here in the Computational Mechanics NanoHub folder. We can get to the syllabus. I can come into like module 1 and start looking at here are the readings, and then down here is like the homework and the project. So if I come into the reading, the first reading of interacting with Python, this is probably a review for most people, but it never hurts to kind of go through. Definitely the hello world. I'm sure if you've picked up any programming language, this is the first thing that you have to do. I don't make the rules. I just know that if you're going to try to learn something, you got to learn how to print hello world. But you can print whatever you want here. Anything you want to say. 6, 7. And there we go. And so the nice part here versus our website is that our interacting with Python website, all the examples are there. The code is here. You can copy it. You can paste it other places and then run it. But I love Jupyter because it has this mix of text, like explanatory text and code, all one right after the other. And all of this text is written in what's called Markdown, and I love Markdown too. So it's kind of like all the cool things that I love about programming, like Python, Markdown, LaTeX, and all sorts of cool stuff. Okay, so those are most of the tools that we need. We'll come back to our syllabus. We have Husky CT for turning in assignments. We have our Jupyter Hub server for running Python and Jupyter notebooks. And then we have our Teams discussion to talk through like problem solving and those kind of things. If you have like a personal issue, then that's okay to email me, but most of the time I'll be ignoring emails in general and just focusing on Teams discussion. So it's much quicker to ask it through Teams as a discussion post than over email. There are too many emails, and they have to do with other things too. So those are our main tools: Husky CT, turn in assignments; Jupyter Hub, do the assignments; Teams discussion, get help from assignments. Okay. All right, so then let's look at what kind of assignments we actually have. First one is a reading coach, and that's the first thing that we'll be turning in. It's weird. All right, so view instructions. Why doesn't it do that from the beginning? There are some things that I love about the new Ultra view, but then other times it just doesn't make sense. Like, why wouldn't I be able to see the instructions when I click on the reading coach? But anyway, maybe that's just me. But I'll view instructions, and now I can see, okay, I have a Copilot Module 1 reading coach, and that's my assignment. So when I click on this, it takes a second, and it'll probably ask you like if you want to run this. It is my learning coach, like my agent. So update now. I'm not sure what that update means. Maybe because I changed some of the prompting. And it should make a new chat with that learning coach. Okay, cool. And get rid of those. So I have two options. I can either learn about something like, and again, this is an AI agent. It's just sort of like it's a autocomplete sort of thing. So if you're looking for like a little more information about a topic, then it can be helpful, but it's not, but you always need to verify what's going on. So let's grab an example from Module 1. Let's go to numerical error. So in this case, I'm going to scroll down. Truncation and round off error. Those are two new concepts that we're going to cover in Module 1 and do some exercises to think about what they are. So let's ask our learning coach. Oh, not that one. And so right now I'm not like doing an assignment, I'm just asking this AI agent to like show me things about what this is. So truncation, and it's an approximate math process, cutting it short, Euler method, okay? Approximate an infinite process with a finite one, or discretization of continuous functions. That doesn't really explain like what truncation is. So truncation happens when you take that continuous function and turn it into maybe a linear function, so a discontinuous sort of thing. And then round off is that finite precision, limited number of bits, yep. Yeah, and this is one example of a base 10 round off. And let's see. And it gives me some code to show like what that is. And sure enough, that's something that we'll look at like in the homework. Okay, then there's other things like you can keep asking it, but let's just start a new chat. Okay, so let's say I've done that a few times, I've gone through the reading, and I want to take my reading quiz. This is telling the AI agent like, hey, assess my understanding. It's going to generate some questions, and I interact with that, and it'll give me an A, B, or C, but that's not necessarily, I'm not going to give you an A, B, or C because a robot told me to give you that grade. It'll be based on the conversation that you're sort of generating along the way. Like, are you demonstrating that you understand it? Difference between a variable assignment and a function call. Oh, wow. Okay. All right. So let's say variable assignment is when I use the equal sign to create a static number or object, while the function call uses a set of parentheses to give inputs to a defined algorithm, maybe something like that, that returns a result or another object. Let's see what that happens. Oh, okay. So this is telling me like, okay, that was great. No problems there. What's the difference between special variables, true, none, true, false in terms of type and usage? And here, I could ask for more help. Like, hey, give me an example. What are you talking about? Result is none, and then here, oh, and then it just gives me then it gave me the answer, but that's okay. Okay, so what? It's going back to truncation and round off. Truncation would be a linearization of a nonlinear function, e.g. Euler method, while round off happens when any number is stored with a 64-bit number. When any, let's say, floating point number okay. Oh, final question. All right, absolute. I was gonna give up, but we'll go all the way. Absolute and relative. Yeah, okay. So absolute error is a difference between measured and expected, while relative error is a fractional difference between measured and expected. E dot G .05 is 5% error. And I guess I could have said, yeah, that this one should have units. So now it tells me I have an A, and let's do this. Can I just say, I just want to copy everything. Can I do that? I just want to grab all of this, copy it, and now in this thing, my submission, I'm going to paste everything right in here. And that's how to that's the easiest way I've found to submit this. There are some other ways that I found of like, I can add these things to, yeah, I can edit it in Pages, and then Pages can be turned into a document. But really, this is all I'm looking for, is like, what was that conversation that you generated with this learning coach? And yeah, so it goes back and forth. And so you don't have to go like question by question. You can push this thing and say like, hey, what do you mean by that? Or give me something harder. So it's here as a way to interact with the reading material and that kind of thing. Any of these assignments, I don't need these confirmation receipts. If you say you submitted it, I believe you. And if something went wrong during the submission, I'll believe that too. There are no late penalties. We do have, it is a 3-week course. So at the end of 3 weeks, I have to give you a grade. So everything needs to be turned in by that final Friday. So that one's this one. This is kind of an aside here, but if we go over to the calendar again and look at the month, this calendar drives me crazy. So by the 16th, that's when everything has to be in, because this weekend I'm going to spend the weekend grading, and then Monday first thing in the morning classes start again and I need to submit the grades. So I need everything by the 16th, otherwise I just can't count it. I just don't have time to count it. So in general, I guess this brings us back to syllabus. So there should be, where's my sidebar? There we go. Due dates and late policy. So if you zoom in and out, sometimes it'll get rid of the sidebar and bring it back, but that lets you navigate here. Okay, so due dates and late policy. You do need something for every due date. If you turn in nothing, then I'll give you a 0. And if you can't submit anything, just let me know. Like, when are you going to turn in the assignment? And then how are you getting help? Are you submitting, do you have like a discussion that you're starting up? Do you have a colleague that you're going to ask? Are you setting up a meeting with me? Like, is it something that you want to work on one-on-one? No matter what you're doing, I just want to know like that you're not just ignoring things, and it's a professional courtesy thing here. Like, when is it going to be in, and then what do you need to get it turned in? Those are the 2 things that I need to know. I'll try to get everything back within 2 business days. So if you turn it in Friday, you should have some kind of you should have some feedback by the following Tuesday. It will make it hard for like homework 4 and project 4. You won't have any time to review the grades that I give you and resubmit that stuff. So if you do these and you really struggle and there's really something wrong, then reach out like as you're doing it, so that we can I can try to help you while you're doing the assignment rather than after the fact. But for all the other assignments, you can submit it, ask questions, like do some work, and whenever you review it on that following Tuesday for homework 1, if you want to make improvements, then resubmit the work and I'll improve the grade after that. So it's unlimited resubmissions. You can submit this work as much as you want. So that's why if there's nothing there, it's just a 0. So submit something, so then I can give you a different grade. But yeah, definitely if there's nothing there, let me know like what's happening. And that's in here. So let's say it's module 1, it's homework 1. So it's submitting homework 1, view the instructions. Right here, I can say I need the weekend to finish, and I can't spell today. Can't spell. I need the weekend to finish homework 1. I posted a question about Euler's method in the Teams discussion. And that's totally fine. Of like, all right, need 2 more days, and there's a question that they need to go check out in that Teams discussion. All right. Okay, so getting back into homework, let's go take a look here in module 1. Take a look at the homework. Each homework has multiple parts. So every part is one of the readings. So here, this is part 1, so it's the reading. So if I want to calculate volume, maybe I'll say this. Nothing appears, so maybe I calculated the volume, or maybe I didn't do it right. So I need something, right? I can use my print statement, print v. But what units are those? It's like, oh, I don't know. Well, up here it was inches, inch by inch by inch. So let's throw in something like this, 1925 inches cubed. And so let's say I'm done. I do this, I kind of work through each of these homework problems. And again, like if you're using your own method of like using Python, I need to know what problems these are. Don't just send me a whole Python file with a whole bunch of code in it, because I don't know what the outputs are. I don't know what's. Jupyter is great for that, because here I can say file, print preview, and now I've got my code and the outputs of my code and all the questions. And for some reason, sometimes this is 1, 2, 3. Other times it's like 1, 1, 1. Like everything's a 1. And I don't know. Such is life, right? Because this one says 3, right? It's okay as long as the code and the question are connected. Then we know at least what we're trying to do. And that's why it's better to just have the question there, or describe, or you can rewrite it yourself. It's like, I have a box that is 12.5 by 11 by 14. Like if you want to rewrite everything, I'm fine with that too. Okay, so make that print preview. So now I have this print preview. Control P or Apple P if you're on a Mac. Turns it into a PDF. So save it as a PDF. We'll go to downloads. Yeah, that's all right. And now I can submit that. And yeah, it'll get there. There we go. And again, I don't need the receipts. So that's the homework. And then project is similar. General distinction between like a homework. So right here, homework, some of it is like kind of straightforward, shorter problems. Project is usually more of like a standalone interpretation, and like even in module 2, you're asked to like actually talk about like why did you do, or what does this mean? How do you predict something with it? Like what? So that's kind of what this is like you can do it lots of different ways. So choose something and try to like make sense of it. If you want to add text to that really helps to describe like what your thought process is in these projects. Homeworks usually are more straightforward. Like you can just have some code and an output, usually answers the problem. Projects, it does really help to have like some kind of thought process of like, why are you doing things this way versus another way? Because there's more than one way to kind of tackle these. Yeah. But it's the same kind of process. Work through the notebook, answer the questions, and then submit a PDF of that print preview. Okay, then rinse, wash, repeat. Module 2, do some reading, do some learning, ask for a quiz, and then work on homework 2, project 2. So everything's all laid out here, like modules 1 through 5. You can work on them in. It helps to go from 1 to 5, but at any timing that you want. Like if you want to get through all of this in the first week, more power to you. And I'll try to get you feedback when I can. For the most part, I'll be doing feedback along this same calendar schedule that we have here. Okay, I'm looking forward to working together. Take a look at the syllabus, get connected on our Teams chat, post questions that you might have, or even just like something maybe that you noticed that we didn't cover in this video, and we'll get to work.